Today we're on pages 174 and 175 of our textbook, Lesson 3 of Unit 6, Factoring Trinomials. The ability to factor trinomials expressions of the form ax squared plus bx plus c is a very important skill. Trinomials can be factored if they are the product of two binomials. So as a warm-up, we are going to multiply the two binomials. So we're going to express the products in simplest ax squared plus bx plus c form. When we multiply two binomials, it's like the double distribution, right? We take 3x times 5x plus 7, so 3x times 5x is 15x squared, and then 3x times positive 7 is a positive 21x. And then 2 times 5x is 10x, and 2 times 7 is 14. And then we combine any like terms, like our x terms here. So we have 15x squared plus 31x plus 14. So we have the trinomial 15x squared plus 31x plus 14. C would be 14, which is considered the constant. 31 is the coefficient of x, which would be the b. And 15 is the value for a, also known as the leading coefficient. Multiplying 5x minus 4 times x minus 2. Again, it's a double distribution. I'm going to take 5x times x and then 5x times negative 2. 5x times x is 5x squared. 5x times negative 2 is negative 10x. Negative 4 times x and negative 4 times negative 2. Negative 4x plus 8. And then combining like terms, 5x squared minus 14x plus 8. And our last product of the two binomials here in C, 4x times 3x, 12x squared, 4x times negative 8, negative 32x, 3 times 3x, 9x, and 3 times negative 8 is negative 24. 12x squared, what is this, minus 23x, minus 24. Okay, so that was just warm-up of multiplying two binomials. So now, and our result was trinomial each time. Now we want to go the other way. We want to start with a trinomial and factor it into the two binomials. So there's two types of factoring trinomials. First, when the leading coefficient, the a value is 1, and then when the a value is greater than 1. So factoring trinomial expressions of the form ax squared plus bx plus c. C is considered the constant. That's a number. It has no variable with it. B is the coefficient of the linear term. And a is the coefficient of the quadratic term. So when we factor, we always look for a greatest common factor first. And when we have these trinomials where the leading coefficient, or the a value, is 1, you see this, the a value here is 1, same for b, c. We find factors of the constant that sum to the coefficient of the linear term b. Okay, so meaning I'm going to, and I suggest you do the same, kind of do like a little factor tree here. What are the factors of 27 that sum to 12? Well, for 27, we've got 1 times 27 and 3 times 9. That's it. And which pair sums to 12 is the 3 and 9. So this simply factors into x plus 3 times x plus 9. B, there's no GCF, the leading coefficient is 1, we go to the constant 24. What are the factors of 24 that sum to 10? Well, I can think, oh, 1 times 24, 2 times 12, 3 times 8, 4 times 6, right? These are all factors of 24, or factor pairs, I should say, of 24. And the one that sums to 10 is the 4 and 6. So this factors in x plus 4 times x plus 6. C, the factors of negative 20 that sum to 8. Thinking 10 times 2, right? And in order for it to multiply to be negative 20 and sum to a positive 8, the 2 would be negative. Right? 10 times negative 2 is negative 20, and 10 plus negative 2 is positive 8. So this factors into the two binomials, x plus 10 times x minus 2. So lots of practice here. This is not new. You had this in Algebra 1. The factors of negative 15 that sum to negative 2, negative 5, and 3. Multiplies to be negative 15 will sum to be negative 2. This is x minus 5 times x plus 3. E, the factors of 12 that sum to 13, 12 and 1, y plus 12 times y plus 1. F, the factors of negative 30 that sum to 7, I'm thinking 10 and negative 3. Multiplies to be negative 30, sums to be positive 7. X plus 10 times x minus 3. G, again, the leading coefficient is 1. Go right to the constant, 16, the factors of 16 that add to 8, 4 and 4. So this factors into the binomial x plus 4 and x plus 4, or which can be written as x plus 4 squared if you like. H, we see we have a GCF. We have something common to all three terms. Let's factor that out. It's a 2. We have x squared minus 14x minus 15. And now the trinomial inside the parentheses here, the leading coefficient is 1. So we go to the constant, negative 15. The factors of negative 15, that will sum to negative 14, or negative 15 and 1. So we factor into our two binomials, x minus 15 times x plus 1. And let's not forget to bring down our GCF of 2. I, there's a GCF of 10 here. Y squared minus 3y minus 40. And now the trinomial inside parentheses, leading coefficient is 1. The factors of negative 40 that sum to negative 3 or negative 8 and positive 5. Y minus 8 times y plus 5. Bring down the GCF 10. J, GCF of 3x. 3x is common to all three terms. Factoring out 3x, we have x squared minus 7x minus 18. The trinomial inside parentheses, the leading coefficient is 1. The factors of negative 18 that sum to negative 7 are negative 9 and 2. X minus 9 times x plus 2. Bring down the GCF 3x. K, there's a GCF of 5. Factoring out 5, we have x squared plus x minus 56. And then the factors of negative 56 that sum to positive 1 are 8 and negative 7. X plus 8 times x minus 7, bring down the GCF 5. GCF of 3 that's common to those three terms. Take out 3. You know, y squared minus 11y plus 30. And now the factors of 30 that sum to negative 11 are negative 5 and negative 6. Multiplies to be positive 30, sums to negative 11. So y minus 5 times y minus 6 are our two binomial factors, and bring down the GCF of 3. Okay, so all of those were when the leading coefficient of the trinomial was 1. Okay. Next, factoring trinomials where that leading coefficient is greater than 1, where the a value is greater than 1. You're going to look for a GCF always. Whenever you're asked to factor, you always take out a greatest common factor if there is one. We're going to multiply the leading coefficient, the a value, and the constant c, and write this product. Okay, so let's see. Start here. All right, so I look at this trinomial. The leading, there's no GCF. The leading coefficient is a 2. It's not 1. So we're going to multiply that 2 by the constant 6. And I say, draw this rainbow, all right? Connect these two, and you multiply them. 2 times 6 is 12. So write 12 just beneath the 6th. And now we want factors of 12 that sum to 7. Find the factors of a times c, which is in this case 12, that sum to the coefficient of the linear term b. So that would be 3 and 4, right? 3 times 4 is 12 and sums to 7. Now we're going to express the linear term, the 7x, as the sum and proceed using factoring by grouping. So in other words, we're taking this 7x and we're rewriting it as 3x plus 4x. Copy down the first term, 2x squared, and the constant 6. So all we've done is we've taken the 7x and rewritten it as 3x plus 4x. Now we have 4 terms, so now we factor by grouping. So let's split after the second term, bring down the operator, take out the GCF of the the first 2 terms, which is x. We get 2x plus 3 in parentheses. Taking out the GCF of 4x and 6 is 2. 2x plus 3 in parentheses. So the 2x plus 3 is one factor, and what's left outside, the x plus 2, is the other. B, no GCF to all 3 terms. The leading coefficient is a 4. So we do 4 times 5 is 20. We want the factors of 20 that sum to negative 12, negative 2, and negative 10. So now we are simply rewriting the negative 12 here as negative 2x minus 10x. Bring down the 4x squared and the plus 5, and now we switch to our 4 terms grouping. Bring down the operator. GCF of the first 2 terms is 2x. 2x minus 1 in parentheses. Here, what's common to 10x and 5 is 5. So 5 comes out, but really it's a negative 5. So negative 5 times 2x would give us negative 10x, and negative 5 times negative 1 would give us a positive 5. So 2x minus 1, what's in parentheses, is the same as it should be. That is one factor. And then 2x minus 5 is the other factor. Simple. No GCF, leading coefficients greater than 1. Multiply, 6 times negative 2 is negative 12. Factors of negative 12 that add to negative 1 are negative 4 and 3. Rewriting negative x as negative 4x plus 3x. So we have 6x squared minus 4x plus 3x minus 2. 4 terms we split. Bring down the operator. take out the GCF, the GCF of the first two terms, GCF of the last two terms. 3x minus 2 is one factor, 2x plus 1 the other. And again, you're welcome to pause the video, go right ahead and try the rest on your own if you like. 6 times 12, 72. Factors of 72 that sum to negative 17 are negative 9 and negative 8. So rewriting negative 17 as negative 9x minus 8x. Now splitting, because we have 4 terms. GCF, let me not forget to bring down the operator. GCF here, 3x, 2x minus 3. 4, we're actually taking out a negative 4, 2x minus 3. One binomial factor is 2x minus 3, the other is 3x minus 4. This is very similar to A, E is. We've got a different sign for our middle term, our linear term. Okay, so 12, that would be negative 3 and negative 4. Would it matter if I wrote negative 4x minus 3x? No, it would not matter. Nothing common there other than the x. Common here is 2, but again you're taking out a negative 2, so you get 2x minus 3 in parentheses. So 2x minus 3 is the one binomial factor, x minus 2 is the other. No GCF to all three. Leading coefficient is greater than 1, it's a 6. So we multiply 6 times the constant 5, get 30. The factors of 30 that sum to negative 17 are going to be negative 15 and negative 2. Multiplies to be a positive 30, sums to be a negative 17. Rewriting our linear term, negative 17x as negative 15x minus 2x. Again, make sure, one common mistake is to put 30 here. No, you want to put down the original constant of 5. And now 4 terms, so we split. Bring down the operator. What's common here is a 3x. And there's just 1, but you're taking out a negative 1. So 2x minus 5 is the one binomial factor, and 3x minus 1 is the other. Okay, and the last 3 here. Again, there's no GCF, so we multiply 6 times 3 is 18. The factors of 18 that sum to negative 11 are negative 9 and negative 2. No. Yeah, sorry. Now, 6x squared minus 9x minus 2x plus 3. 4 terms. Split the first 2 and last 2. Write down the operator. Take out the GCF of the first 2 terms. And the last 2, they just have the 1 in common. And again, you're taking out a negative 1. So 2x minus 3 is one binomial factor, and 3x minus 1 is the other. No GCF to all 3. Factors of 6 that sum to 7 are 6 and 1. 3x squared plus 6x plus 1x plus 2. 4 terms split, so we're grouping. Bring down the operator. Take out the GCF the first two terms, and of the last two terms. So x plus 2 times 3x plus 1 is our factorization. And our last one, no GCF. Leading coefficients greater than 1, it's a 2, so we multiply 2 times 5 is 10. Factors of 10 that sum to 13. Well, there aren't any. So 1 and 10, and 2 times 5 is 10, that's it. And none of which sum to 13. Okay, so we call this prime. This is prime. It's not factorable. We say when it's not factorable, we say it's prime. Thank you very much for your attention. Again, this is not new. You practiced all of these two types of factoring trinomials in Algebra 1, so hopefully you recalled everything.